Okay, I made a couple of brass bungs. This one here is gonna. This one here has a through hole. It'll have a muffler out the top, 8/27 thread pitch for NPT. The bottom one is a 3/8/16. I'm gonna run a machine a stud with a through hole in it, so it'll be the exhaust for the air cylinder, which is what this will be. Next over is I'll use the mill, and I'll mill a couple of flats across here to put a wrench on it. Here's the other one I just got through machining. I faced it, turned it down about 10 thousandths off just to get a nice finish off of the bar stock, and then I took and just ground a, hopefully you can see that there, a radius on just a piece of high-speed steel to come in and touch off and put a nice machined radius on that. And you can see I use my playing card trick again, so I don't get any vice jaw marks on it or any marks from where I just formed it or marked it up. So I'll pull that out now, and then this will go over for the mill also, and I'll put a couple of flats, one on each side, and then I'll come in perpendicular and drill all the way through to coincide with the hole in the back side. So this will be the feed for the cylinder, and an 1/8 inch NPT on either side, 180 degrees. I'll just drill straight through, drill and tap each side, and put the 90 degrees with the check ball and the needle valve on them, and this will be right on the bottom of the cylinder. So I'll go do that and be right back. Okay, so I've got my end piece, or my piece that's going to feed the air cylinder set here in the vise in the mill now. I'm using my playing card. I just tore it in half. These are smooth jaws. I doubt I'd mar the surface, but that surface finish turned out so nice on the lathe. I don't really want to risk it at this point, so I just put a playing card there, set it down on a parallel. There's a hole drilled in this side that I've already tapped 1/8 inch NPT. There'll be a little nipple, and this will actually thread into the air cylinder. Then I'm going to find center side to side in the x-axis, and then this measures 1 inch. I think that's what I made this at. Yeah, 1 inch. So what I'll do is I'll come in and touch off the bottom edge, come in 1/2 inch. This hole down here I've come up 3/4 of an inch. So I'll come up 1/2 inch, that way I know I'll intersect it. I'll drill straight through 180, so the holes will be 180 degrees apart. I'll drill straight through. I'll tap both sides 1/8 inch NPT to put the 90 degree check valves with the needle adjustment in. So I'm going to come in and touch off both sides, find my center, come in and touch off this edge, and come up 1/2 inch. So I'm going to go ahead and do that now. Put my drill chuck in, put my edge finder in, and let's come in and touch off this back side first. So I'm going to move it out until it just starts running true, and as soon as it kicks, boom, as soon as it kicks. Now I could either zero out I could do one of two things here. I could either zero out my Y and then move it 100 thousandths, because this is a 200 thousandths inch edge finder, and then re-zero it again, or I can go into the DRO and I can just offset it by 0.100 and then move it. So I think that's what I'll do. So I'll go in here and go Y 0.1, enter. So now if I let's see, so Y 0.1, enter. So I'm 100 thousandths. Now by coming offset of that 100 thousandths, so my DRO reads 0, I'm actually 100 thousandths off from where I touch the edge, so I know dead center of that edge finder is right over that edge. Then it's just a simple matter going over 500 thousandths. 4 and 500 thousandths. I'm 1/2 inch exactly up from this edge. So now that I've done that, I'm going to go over to the edge, and this is where, because of the radius of it, you have to come down to you just touch, or so you just get a touch, but you don't want to hit this top edge of the edge finder. You can mark it up that way. So I'm gonna just offset my edge finder there. So I want to touch on the bottom, the 200 thousand diameter, not this 3/8 inch up here. So I'll come in, it just starts running true, it's running true. Boom, just kicks. So X, I'm gonna 0. And come over the other side. Come down. Move it in until it just touches. You see it starting to run true, starting to run true. Start truer, truer, and it boom, just kicks right there. So now I'll just come in, I'll go half X, and it says I've got to move over 718 thousandths. So now I can just go ahead and move that over until I read 0, which is right there. So that's dead nut center from this side to this side when that reads 0, and I bumped my Y 1,000th. So I will come back on that one, boom, and that's ½ inch up there. So I'm going to go ahead and center drill that. Okay, so I flipped it over. I mean, there's multiple ways you can go ahead and set this up. You can measure off of it, come in and find something. I just found that this isn't a real super critical. I mean, it is, but it isn't. So what I've done is I've just taken the drill bit and set it in there, and then I'm going to take just a machinist square here, and I'm just going to set that on there. And I actually got that pretty close just from eyeballing it. Yep, that's pretty true right there. Just by eyeballing it there. So I will come down and move this into place. Come down, I just touch off even on both sides. Okay, so again, I'm going to put just a little bit of Molly D on this 1/8 inch NPT tap. Put it into the take my mill out of gear there, and I'm just going to run it down, run it in by hand. And lock it, break that chuck loose, keyless chuck loose, put my tap handle on, and tap it, and boom, that one's done. Oop. Okay, and while I'm here, I'm just going to go ahead and just come down and put a slight chamfer on that. Make it look all nice and pretty. Pull that out, and there's my 1/8 inch NPT and 180 degrees apart. Now I just need to turn it and mill 2 flats in and put a wrench on it. Okay, I've got my piece set up here. I went ahead and put it against the V-block here. I set on some parallels. Ideally, I like to put the V-block against the fixed jaw and then push up against it. However, on this one, this vise has got a little hump down here that seems to be, it doesn't let my V-block sit flat, and it was taking, I didn't have enough hands to hold everything as I was tightening it up, so I just flipped it around and just snugged down on it. I've got the through hole lined up perpendicular with the table here, so it's in plane with the Y-axis. So now what I've done is I've hit my edge finder, I've come down and touched stuff on this edge, I've moved over, I'm going to use a 1/4 inch end mill, and I want to just take a 1/4 inch off of that, across there. So I've touched off, found my edge, and then I've moved in 1/8 of an inch, which should give me, which is the radius of the end mill, so it should give me a 1/4 inch right from the edge there. So I'll go ahead and take my drill chuck out. Grab me a 3/8 collet. Put my end mill in. And let's see, let's set up my quill stop. Go down a little lower than that and make sure you can see good. So I'll set my quill stop up, and I'll come up, and I'm not quite sure how deep I'm going to go to start with. I want to be able, I don't want to go too deep. I don't want it to look crappy, but I want it to be enough that I can put a wrench on it and not actually have it round the edge off and have enough meat to put a wrench on there. So this is going to kind of be, it's not real critical, it's just more for aesthetics at this point. So this is going to be just a little bit of trial and error here until I get the depth I want. So I've got my X moved over 1/8 of an inch from the edge, so 125 thousandths, which gives me my 1/4 inch diameter. And then I'm going to turn it on and move up till I touch it, and then go, I don't know, down till I feel like it looks good. I'm actually going to go a few thousandths off on 125 thousandths there. I'm going to go back out to 115, or 115. I'll take 10 thousandths for a finishing cut. So let's go ahead and plunge. I'm just touching right there, so I'm going to zero out my Z. And I'm just coming down. There's 50 thousandths. And there's 100 thousandths. Go a little bit more than that. I don't want to go too much, I don't want to get down into the, well, I'm not going to be going in that far, so maybe I'll go down an 1/8. Let me see what an 1/8 looks like. So there's 125 thousandths. Let's, actually, I think that'll look good. Let me go ahead and go down to an 1/8. So I'm just going to kind of plunge this along here. It's brass, it's soft enough. I probably didn't need to plunge. I probably could have run that straight through, but I kind of like to plunge wherever possible. So I'm going to come back, and I'm going to run this. I'm down against my stop, and I'm going to run this, knock those high spots off. Okay, now I'm going to come in my full depth, and I'm going to do the last one with a climb cut, so I'm going to come into 100, come over 125. Right in the money there. Leave a nice finish. Boom, that one. Okay, so I'm going to go down, I'm going to come up, that was 125 thousandths. I'm going to come up and probably, let's just shoot for, I want to make sure to get a wrench on there good enough to where it's not going to mar the edge. So grab one of my wrenches and measure the thickness real quick and kind of get a feel. There's no sense in going any deeper than the wrench is thick. Now wrench is about 240, so probably 1/4 of an inch. I'm going to go down to 200. I'm going to go down to 200 thousandths. That's 75 thousandths deeper than I am. Well, let me go 175. So there's 175. So now I'll go ahead and try that. Actually, I'm just going to leave the tool down. And, right, yeah, that's the ticket right there, 175 thousandths. So now that I've done that, I'm going to come in. I'm going to come in another 5 thousandths just to clean up that edge. So I was at 125. I'm going to go to 130. And I'll remember to do the same thing on the other side. There's 130 and full depth. Finish going. Beautiful. That's the ticket right there. Okay, now I'll go ahead and make my same dimension, my same calculations on the other side, and that'll be the ticket right there. Okay, benchtop update here. So I've got my two brass pieces made. This one here is the one that's drilled 8th NPT for my little muffler there, and then the bottom is 3/8 16. So what I'm going to do next is set it up on the mill and determine the exact spacer here. I think last night I determined it was going to be around 5/8 of an inch. So I want to set it up on the lathe and double check, because I think I'm a little high here, so I don't know whether my travel will be limited, or if I can go ahead and take maybe an 1/8 or 1/4 of an inch off these 3-inch spacers here. I'd rather make them a little long for my test fit. So anyway, I'll set up there tomorrow night and look and see where it's sitting, make my spacer, and then I'll make a rod or a stud that's hollow, so it'll be tight, it'll be tapped or threaded in 1/8 inch NPT here, come down through here, down through the spacer, and then 3/8 16 on this end. So I tighten it down. It sandwiches the cylinder, the spacer, and this top plate all in one. That way it'll all travel up and down together. I don't want to bottom out my ram, so that's why I'll take a measurement. Here I've got my bottom one in to where you can see I've got the little 1/8 inch nipple back here. It's just barely setting in. It's not threading very far. It'll actually probably close up another, oh, I don't know, probably 1/4 of an inch by the time it's all said and done. And then here's my two little check valve needle valve assemblies. So I will go ahead and thread those in, and then I just have to drill and tap up on top here for the other T's, so the lines will come over, drop down to here, and then come here and go over to the controller, which is okay. I'm not sure how Colin did his. This was my solution. I'm assuming that's similar to what Colin did on his, but this is what I come up with. It's just a piece of 1144 that I turned down. It's 3/8. I put an 1/8 27 NPT on one end and a 3/8 16 on the other, which is what this is drilled and tapped at. There's my muffler. So this will thread into there. Actually, I'll put some sealant on there, obviously, but that threads into there. This top plate goes on. And that comes up through. This threads down and locks, and then this will be the exhaust, and this will be obviously my feed coming in there. And I ended up not needing a spacer in there. By the time I got it all set up and set down on there with the socket, I needed about, it seems like it was, if it was all the way bottomed out, I was about an 1/8 of an inch. Because what I ended up doing is I ended up putting a nut underneath the stud here, or the ram, the rod, so that I could lock it. and therefore it changed the overall length of this a little bit. So I ended up just snugging it right up to the top there, and this will be tight. All I have to do now is drill my 2 holes in the top plate here for my T-fittings and thread this part together, and this part's done, and then I can just work on my control handle. So I'll be should be able to finish this up here in a few minutes. But yeah, it rides up and down nice and smooth, and when it goes all the way down, it won't bottom out on this before the socket pushes on the drawbar and pops the taper loose up in the spindle. So it won't bottom out. It won't bottom out. All right, got her all installed up on top of the machine, and let's do a test run here. Dropping the drill chuck out. Out. And back in. Works beautifully. There we go. You can see closer view here. Got the check valves with the needle assembly here. Works perfect. Thanks again, Colin, for the idea.